Now with the scatter plot, it's always required that we have two different sets of two different distributions. Basically, we have two different data sets which are connected based on the relationship between them. But each one of them we could treat separately and say, well, what is her mean quiz score? What is her mean time spent studying? What is her median, et cetera, et cetera? And actually, a lot of those things are helpful in determining Amanda's the correlation between these scores at the end of the day. So number 4 says to calculate X bar and Y bar, which remember that stands for the mean basically for each one, and then S sub X and S sub Y, which just that remember the S stands for standard deviation, and with the subscript X and Y, that would just mean find the standard deviation for X and Y separately. So for X is the time she spent studying. We have not actually been dealt with those numbers yet. But basically, if we wanted to find X bar, that would be her average time spent studying for her quizzes. So we need to add them all up and divide by 7 because we have 7 data points. So let's go ahead and do that. Grab my calculator here. So we have 3.5, oops, type 3.5 plus 4 plus 0, I'll skip, plus 3 plus 2 plus 4.5 plus 4. And that would give us, she spent 21 total hours studying. Divide that by 7. Data points yields 3, an average time of 3 hours. So that would be her average or mean study time. And we calculated her average time, or her average quiz score last time, which I believe was an 87, was her average quiz score. So we'll just, instead of doing that again, we'll just copy it from last time. Also, we calculated her standard deviation for Y, which I believe was 15.64. I'll double check that after I finish recording this video, and I'll fix it if I'm wrong. But and basically, so we don't have to do that again. But one thing we still don't know is what about her standard deviation for X? So let's go ahead and do that as another review for standard deviation. So to find the standard deviation, recall that we need to figure out what are all the deviations, square them, add them up, divide by n-1, and take the square root. So quite an elaborate process, but basically for each of her score, since S sub X would be her standard deviation for X is her time spent studying, it might be wise to mark that above our graph just so we don't look at the wrong data. But basically, let's go ahead and calculate the standard deviation. Remember that the deviation is the difference between each data point and the mean, and the mean here was 3. So let's go ahead and just write, I'll make a column over here for deviations just so I don't have to recopy it. I'll do X's deviation right here. And since we just figured out that her mean time spent was 3 hours, well, for the first data point would have a deviation of 0.5. The second one would be 1. Again, you're just doing this one minus the mean. 0 minus 3 would be negative 3. 3 hours was exactly on her mean. 2 was 1 hour underneath her mean. 4.5 was 1.5 more, and 4 was 1 over. So I'm just taking each of those numbers and subtracting 3 to get the deviation. And to do the standard deviation, I need to square those first, add them all up, and then divide it by always n-1. Similarly to taking the average, but it's always by 1 less because there are always 1 less degree of freedom in these cases. So I'll go ahead and type this into the calculator just to save a bit of time. And you could, of course, use a calculator or Excel or something, or R, to find the standard deviation for you, but might as well do it while we're, since it's not, these numbers aren't too bad. So we'd have 0.5 squared plus 1 squared is just 1, plus 3 squared is 9, plus 1 plus 0 squared plus 1 squared is 1, plus 1.5 squared, and plus 1 squared is just going to be 1 as well. So basically, the standard deviation, we need to add up all of the squares of the deviation, which is the first step, and then we divide that by n-1. In this case, that would be 6 instead of 7, 1 less than the data points. So we would get and remember, this is what's called the variance, s squared. S squared is equal to that, 2.416 repeating. And then if I take the square root of that, I would get the standard deviation for the variable x here, which is approximately 1.55. And let's go ahead and note that below. So S sub x is 1.55. And there we have it. And we'll use this again later when it comes toward finding the correlation, finding the least squares regression line and the line of best fit. All of that is reliant on knowing your means and your standard deviations.